We're going to look at a couple different types of redox reactions in this video. And the first one we're going to look at, and this is something you've done in the lab, is the reaction between a metal and an acid. Again, this is a kind of special type of redox where some metals, and you discovered this in lab, but some, not all metals, react with acids to reduce H plus to hydrogen gas. So one example that you did in lab was you took magnesium metal and you added hydrochloric acid to it, and it produced magnesium chloride, which is soluble in water. So you didn't see that. But what you did observe was as the magnesium disappeared, hydrogen gas was formed. You saw the bubbles being evolved. So this is also kind of technically a gas forming reaction, which we talked about earlier. But it's also redox because if we look at the oxidation numbers for these atoms, magnesium is 0 because it's in its elemental form. You could say the same thing for hydrogen. It's 0. And Cl, chlorine, is almost always -1. That would make this hydrogen +1. And then this chlorine, again, still -1 here, but there's 2 of them. And magnesium is a group 2A metal, so it has an oxidation state of +2. And if we look at this, magnesium went from 0 to +2. It lost electrons. And the hydrogen, H plus here, gained electrons. So the magnesium got oxidized, and so we would call it the reducing agent. And H plus got reduced, and so we would call HCl the oxidizing agent. Now, the other type of redox reaction I want to look at are combustion reactions. So again, yet another type of redox. And just like the name kind of implies, we're setting things on fire. But it releases energy in the form of heat. And generally, the reducing agent is the fuel for a reaction. So like, for example, when you burn propane, like in a barbecue, propane, that hydrocarbon, is the fuel for it. And the oxidizing agent is most often oxygen in the air. So all, or I don't want to say necessarily all combustion reactions, but many of them, especially if they involve a hydrocarbon, one of the reactants is going to be oxygen. Now let's look at an example of this. So this C2H2, this is acetylene. So some of you may be familiar with this, like acetylene blowtorches. But acetylene reacts with oxygen in the air to form carbon dioxide and water. Now I'll just go ahead and quickly balance this, but if you want to get some practice with balancing equations, and this is typical when you combust a hydrocarbon, and the reason they call this a hydrocarbon is because its formula contains hydrogen and carbon. Anytime you combust a hydrocarbon, you're always going to get carbon dioxide and water as a product. Finish balancing there. There we go. So let's kind of go through and look at how this is oxidized and reduced. So we have oxygen here. It's in its elemental form, so it's always 0. And then we got hydrogen here. Hydrogen is going to be +1 since it's bonded to a nonmetal. And that means each carbon here is going to be -1 to balance that out. Now, if we go to oxygen on this side, here, oxygen is -2. We got 2 of them there, which makes that carbon +4. And then again, oxygen -2, hydrogen here will be +1. So let's kind of identify what has happened here. In this case, carbon has gone from -1 to +4. Has to lose electrons to do that. And oxygen went from 0 to -2. It gained electrons. You can see that in both CO2 and water. So if we're going to look at this, we'd say carbon got oxidized, and we'd say the acetylene, C2H2, is the reducing agent, and O2 got reduced, which makes it the oxidizing agent, which we said is very common in these combustion reactions.